Okay, let's carry on from. Okay,
Yes,
so
please, we are here.
yes, so let's carry on from where we left off. If you have a question, ask me as I go, please. So, like I said, we'll be talking about object-oriented programming, which is a concept, a way to program. And when you hear little children, very young people learning how to program, that's because they are using the object-oriented programming concept. Okay, so we learn how to design a program. I'll give you assignments. You have to write a program and send it to the following week. If you don't give it to me, we only have like 3 weekends also. So when I give you something, you don't do it, it's like it's a really bad one. Programming flow and testing and debugging. So of course, these are the things that programmers do. We'll learn about functions and what they are. Functions, taking values, and then they return values. Arrays. So we talk about scalar variables. Okay, and we talk about array variables. And then user interface design. That means I will design our interface by dragging and dropping. Are you okay? So we do a practical so that you can appreciate what programming is about. We'll be making use of Visual Basic Express, if you like, or you can use Visual Basic, any version that you get, grab it and then make use of it, write your program. So Visual Basic is very easy, it's okay. And that is why we're using Visual Basic. So please start downloading it tonight, tomorrow, Sunday night. Download the program, excuse me, and then start studying it. Okay, don't wait till I say we are working with it and then you're now looking for it. It may not work on your computer, remember. So don't shock yourself. Is that okay? Don't shock yourself. That's the interface. I don't know if you're looking at it. Yeah, that's the interface, guys. Download it, install it, open it up. Even if I'm not asking you to do it, you don't know how to program. Installing the software is for, you know what I'm saying? Anybody can do it. Anybody can do it. So, like I said, I have a niece who's a programmer, so don't disappoint me, guys. I'm very happy to trail you if you don't take it seriously, because I know you are not serious. Some people are just not serious with anything that we are doing. All right, so what is it about computer programming? Okay, we write a set of instructions. So guys, instructions are like going to buy someone sending you to go and buy wachi. All the things you do, okay, so buy, go to, since Nordness usually sell wachi, I'll use a Nordness name, Mamuna. Go to Mamuna to if he selling by wachi CDs. Okay, so this is data and instructions all put together. Then go to the shop, the blue shop. So if the shop is blue, then she'll go there and buy Ayoki water. That's it for end. So this is a program. So programming is all around us. Ayoki, it's a set of instructions, all right? And then these instructions have to be tested. Why? Because it may not be correct to give people instructions like this. It's possible this instruction is actually, it doesn't make sense. It's possible it doesn't make sense. Are you okay? But so if you make a mistake in giving the instruction, it's just like meeting someone who is like, excuse me to say, someone who is not mentally okay, and then they asking you to do something. There's this funny one where the madman asks, offers to actually help a car to reverse backwards. And then he just says, come, keep coming, keep coming. And then the car drops into a hole and he says, okay, it's fine. Now you're in the hole. Like you can imagine that set of instruction is not the type you're talking about. It has to be tested. So when we write programs, usually there are a lot of what we call bugs in it. So we debug, remove the bugs from the program. So you can write a program to add two numbers, and then when you say 1 plus 2, then you are getting something else. Okay, 1 plus 2, and the computer is giving you 4. And we all know that that isn't correct. So we have to debug, remove the bugs from it. Okay, we need to maintain the source code. So sometimes you see, you just don't write a program, you keep on updating it. So that is part of maintenance. The program is also written to solve a specific problem. Now let's remember that there are different problem domains. Are you okay? There are different problem domains, and every problem and the way it's solved. For example, if you want to write a program to actually allow people to play a game like my in-law is doing behind me right now, then you have to write it with the appropriate language. Normally we use C# for programming. Is that okay? Programming is used for C# is used for gaming. Okay, so you write the program for gaming, you use that. If you want to write a program in an airplane to control how the airplane moves, you want to use C. So C is an embedded program. You can write C in such a way that it starts talking to a device. Like for example, if you want the flaps to come down, I don't know if you boarded a plane before, you know what I'm talking about. The pilot doesn't go and turn the flaps. He presses a button that sends a message to the flap, then it starts turning green, and you are coming down and all that. And also we know the accident of the Ethiopian airline accident. It happened because the autopilot kicked in and was fighting the pilot, is the real pilot. So you can imagine that these are some of the problems with advanced programming, which we probably will want to call artificial intelligence today. Okay, so programming is so important. Everybody want to be a programmer, but we have to learn it. Are you okay? We can solve general scientific problems, okay, or business problems, and there are different programs that can do that. Okay, but obviously it depends on the skills. Okay, early developments made use of robots, as what we call the Al-Jazari robots. In fact, growing up, I remember there were these toys that played by themselves. They were playing drums. Are you okay? So once you press a button, they start playing. So any automated system, start thinking about a program. Okay, the Jacquard loom. Are you okay? Which made use of paste cardboards and then punch holes in them. Was the beginning of what programming, and then data storage. Are you with me? Because data is what you need to write your program. You need to put in data and then process it. Are you with me? So if you don't invent a way to store data, you can't. Are you okay? Go into programming at all. So the development, over the industrial ages and all that industrial revolution, it programming has gone through the processes. Are you with me? But it's quite recent. With the advent of computers, you could do programming. Okay, so we can talk about the history, but it's not really, that's not my interest. Let's move on. We can talk about the von Neumann architecture and all that. It won't come in exam, but just get to know that it started somewhere. Programming didn't just come all of a sudden to us. Are you with me? All right. Early programs had to be painstakingly crafted using instructions for particular machine. So in other words, gone are the days. You see, today I can send you a program and you run it on a computer. Gone were the days where you have to write particular instruction for a particular computer. So if I'm writing it for my laptop, it will only run on this laptop. Can you imagine that? All right. And then it made use of what? Binary notation. So if you don't know binary numbers are like zeros and ones. Okay. So can you imagine counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? And when you reach 10, then you start recombining them again. With the binary notation, when you get to 1, as you get to 2, you turn back and start again. Are you okay? So in binary, if you say the number 4 is represented in binary by zeros and ones, okay, you can work that out. I think there's not a math class. I won't waste time on that. Please just investigate into it. Try to understand how these numbers are okay. Different bases, number bases. Yeah, base 10 is the one we are used to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are okay? That's binary. Okay. So, yeah, every model of computer will likely need different instructions, blah, blah. This is the history. This is where we come from, automation, all right? And then we can talk about assembly languages, okay? And then in that case, then you could actually put in some abbreviations like add, sum, total, things like that. All right. So in the 1954s, thereabout, then, Fortran started coming in. Fortran 77. Are you okay? It's a kind of program that worked. Okay. Now you could actually do some calculations like what we've seen on the board. X times 2 plus 5 times X, things like that. You could just do that. So obviously Fortran is good for engineering. Are you okay? Different languages work well for particular problem domains. Okay. There are so many programming languages. Fortran is there, Basic is there, Visual C++, C Sharp, J Sharp, Visual Basic, yeah, JavaScript. Java itself has different flavors. Now we even have what we call frameworks. So someone writes a program and then someone writes a framework on top of it. That makes writing programs easier for you. Are you okay? So there are more programming languages, but the concept remains the same. Are you okay? All right. So like I said, it's possible to use different programming languages for different problem domains. So the program and the problem. So programs are written to solve problems. Are you okay? Programs are written to solve problems. Are you okay? At this stage, I have to speak without opening my mouth too much because programs and problems, if you're not careful, you bite your tongue saying that. All right. Expert knowledge is usually required in order to make a choice, blah, blah, blah. Are you with me? How do I know whether I should use C# for this particular problem? But we realize that, you see, I have done some games before. I've created a game before, and most of the time they're using C#. Okay, Python is also there. Python is being used a lot these days for web app development. Okay, etc. Okay, and then you can talk about JavaScript also for websites. Okay, Java is very, very good for websites. People are writing programs with it. Okay, all right. But what should a good program do? If the program is good, then the program should be efficient. When we talk about performance, the program should be efficient. That means that you don't run one program and then it crashes your computer. I told you that I didn't have memory on my computer, and usually it's because I'm running a particular program. If now I have 2.82 gig on my C, okay, and that seemed to be like a lie, because at a point I have more than that. At a point I don't have anything and I don't know what I did, simply because I'm running a particular program. Are you with me? So when you run a program, when you write a program, it should be efficient. When you write a program, it should be efficient. Okay. All right. It shouldn't also consume too much bandwidth, because there are some programs that make use of the internet, data from the internet. So you should look at bandwidth, network bandwidth. Okay. It should be reliable. So you don't have a program that one moment gives you different results. One moment 2 times 2 is 4, and then the next moment 2 times 2 is 6. You're like, what is going on here? It's getting spiritual. Are you okay? So these are the qualities of a good program. It should be robust. That means that it should figure out that, oh, someone, are you okay, may put in 2 or 3. So let me actually force the person to put in the number that I want as an input. It should be usable. The ease with which a person can use a program. Some programs are just not user friendly. Are you okay? You just don't know where to click. It's not that you just don't know what to do. So it's not usable. And usability studies are really kind of one of the areas that are trending at the moment. You see, there's a lot of research in usability study, and that is why programs that we use today, are getting better and better, and that's why we keep on getting updates. If you know, WhatsApp gives you updates. Yeah. Portability means, we all know portability in Ghana. The word portability has been used. Are you okay? When it comes to our mobile network, the telcos, telecommunication, okay, porting the numbers, and we want to make sure that when you dial *124, that's the same thing on Vodafone and the same thing as MTN. Portability means it refers to the operating system. Are you okay? So the range of computer hardware and operating systems. Are you okay? So we're talking about 64-bit, 32-bit computers. Are you with me? All right. What is an algorithm? So an algorithm really is a finite list of instructions describing how to transform information from inputs into outputs. This is a question I got in an interview when I wanted to travel some years back. Okay, I told, I think, David about it. They were like, what is that? And that passed me, So maybe you never know, maybe it's your turn. But an algorithm or algorithmic problem solving is a stepwise way of solving the problem. So you write a problem, you break down the problem into steps, if you like, the solution to it. Okay. And then you should have a machine that can execute the instructions. That's all. In other words, if I have a set of instructions to go by Wachi, I should get someone who I'm going to send with. Okay. Now, the program shouldn't run forever. It should run within a finite time. Are you okay? Algorithms can be defined without reference to transform information. In other words, you don't say, okay, I want you to show me how you pick someone from the airport, and they tell me you go and pick the person. I mean, like, is that a solution? I said, show me how. So you need to break it down and then tell me that you have to pick a cab first. You need to get there. You need to wait till a certain time of arrival. You understand that? So one, you have to understand the problem. That is one. The first step is writing an algorithm or a program is understanding the problem. Are you okay? Okay, algorithms can be defined without, I've talked about already, simple enough. So algorithms should be simple. You don't make it complicated already. The problem itself is complicated. All right, so here's a simple algorithm to meet a friend at an airport. You can debug it. It may not work, okay, but you can look at the step one. So when I ask you to write an algorithm, you have to give me the step numbers. Step one, step two, step three, step four, step five, till you get to the end. So step one, take a bath and dress. Step two, get a taxi to the airport. Step three, alight. Step four, wait. If a friend has arrived, go to step six, else go to step four. So you can see that we keep on checking. If the person's arrived, okay, then we go back to step four and wait more. Has he arrived? No, keep waiting. So you write this for someone who is not very smart, okay, and then they can take it and they can work with it. He says I should take a bath so that I could look nice and neat. Two, he said I should get into a taxi going to the airport. Now you can see that we need to get a taxi back home. So this algorithm will get a person to the airport and back. Let's assume the person is just so dumb. Are you with me? God forbid, the person is so dumb and slow. Then we may want to write these steps for the person. So algorithms are there. If our programs, apps, you're talking about the apps on your phones are what I'm talking about. Don't think too far. I'm talking about programs that you run on your computer, like VLC Media. I'm talking about Windows Media Player. I'm talking about AutoCAD. Talking about GIS software like ArcGIS. That is what we want to learn. Scratch is also a program. Are you okay? My teaching assistant is telling me, are you okay? All right. So expectations of the computer algorithms are that there should be a finite list. Things, it shouldn't be like you write an instruction, you never end. It should end. There should be a mechanistic execution. In other words, you move from step to step. I've closed. I was writing one right now. I've just closed. I would have shown it to you. So no program, not even your WhatsApp. Your WhatsApp works like that. There are instructions and they move like that. Back, move, stand back, go back, start again from that step, and then carry on from there. There should be finite execution. So finite execution means that you execute and you get finished and you close. You don't just continue forever. Okay, so the first thing is to understand the programming process. Are you okay? If you want to actually write a program, understand what the programming process. There are 6 programming steps which we are going to go to. First, understand the problem. So let's say you are a surveyor and then you've been sent to a mining area to go and do some work. First, if you have to understand mining to some extent, what are they doing? They're going underground. So all the principles you learn on the surface won't work. So the same thing applies to what? Computer programming. You need to understand the problem at hand. Then you can even think about going ahead. Are you okay? All right. So here, resources department needs a printed list of all employees. Are you okay? The billing department wants a list of clients who are 30 or more days overdue. That needs to be understood. What exactly do they mean by bill? What is a bill? Are you with me? Okay. So what is a list of clients who are what's his age? Age, if you don't even know what age is about, how can you write a program for it? The next thing to do after understanding the problem. So if someone say write a program to solve a quadratic equation, you need to understand how to solve a quadratic equation first. By hand, you should be able to understand, oh, okay, this is what happens. I'm supposed to use the almighty formula AS plus BS plus, you know, gives me that. Are you with me? Okay, AS squared plus BS plus C, something like that. That's the formula. Then A, B, C, these are the roots of something. Are you okay? The coefficients, and I can solve for the roots, and I get X equal to that or that. So then you can start writing a program for it. So at the end of this, I want all of you start thinking about a problem you are going to write a program for using Visual Basic. Okay, because you never know, maybe next week we are starting. Plan the logic. Are you okay? What is logic? A lot of people don't even understand what logic is. But logic is very, very easy to understand. Let me tell you what logic is. Logic is saying that, okay, go and kick the ball if it is in the middle of the park. Okay, so this statement has some logic in it. Are you okay? So there is one condition. You don't kick the ball until they find the ball in the middle of the park. Then you kick it. Is that okay? Now go kick the ball if it is red and in the middle of the park. Now here is getting interesting. Is that okay? So here you need to find a red ball in the middle of the park. Then you kick it. Is okay. So the logic is the logical operator is end. So in the middle of the park is one side of the operation, and then ball is red is the other. Okay, so ball is red, operated by end, the middle of the park. So the logic, this is logic. So logical operators always make use of the word and or, and we'll talk about 2 more logical operators to help you in this class. So logic is very important and is at the heart of the programming process. Are you okay? So anybody who does programming is the type that knows when you give them instruction, they will listen to it. That's why you see me always get it. I don't get angry, but I get worried when there's an arrangement between you and me, and then you are not doing your part. I really get, I keep asking myself, I mean, what is going on? Are you okay? But normally people are tired. That is why they don't follow instruction. That's why I also think everybody is intelligent to their own level. Okay, so guys, logic is very, very important. Are you okay? The phase of programming process, the programmer plans the steps to the program, deciding what steps to include and how to order them. In other words, when should we execute which part of the instruction? Are you okay? All things being equal. So we are moving mechanistically, but then we are moving a certain order. In other words, we can decide to execute step 6 and jump step 3 and 4 and 5 simply because certain conditions have been met at step 2. Okay. All right. The 2 most common tools are flowcharts and pseudocode. So in other words, you see, we need to plan the logic with tools, and the tools are what? The pseudocode and then the flowcharts. So we are going to talk about flowcharts and then talk about pseudocode very soon. All right. The third step in programming is to code a program. Simply code. You now have an idea, the logic, the steps that I want to do the step 2 should do it. But now write it in a language. Are you okay? So let's assume you know how to drive a car. Okay. And then now you need to teach someone who is someone who speaks only French, understands only French, how to drive the car. How are you going to go about it? So you know exactly what should be done, but you just don't know the language, are you okay, to communicate it. So now you need to now convert all your knowledge and everything you think and the logic of it into a language. So you need someone to translate. Are you okay? All right. So that is what coding the program is about. You use what we call the syntax. Okay. In programming, there's something we call syntax. So syntax is the order, the actual language, the structure, are you okay, by which we actually write. So I'm going to just give you a typical example of, so I can just do dim a, okay, for a go to 1 to 10, a, okay, 2a. So you see, you probably don't understand what I'm doing, do you? Or you probably do, depending on if you are knowledgeable. So someone understands French and they speak French. Merci beaucoup, s'il vous plaît. Yeah, assez toi, assez toi. He's saying all these things. What did I just say?
It's not correct.
Oh, but I said merci beaucoup. Is that not correct?
Yes.
Yes, assez toi, madame. Is that not correct? My niece is challenging me here. Teaching assistant. Please, I'm the man. Okay, I'm the boss. So the step here is doing something. Here is doing like, so it's like I'm speaking French or I'm speaking Dutch. Are you okay? So that's what coding is all about. The reason we are calling it a code is that, you see, if you decide to code, and some students are coding in examination hall and they are cheating and they are coding. You understand that when it does this, it means B. When it does, it means, please don't be learn a proper way to code, not learning how to cheat. That type of coding is not good. Okay. And we have people who are actually hacking into computers and all that. In fact, these are all not good things to do. All right. So guys, basically that is some code for you to look at. That actually is in Visual Basic. But when you want to write that in another language, it will look totally different. Are you okay? You want to write that in JavaScript, it will be different. If you want to write it in yes, Python, it may look totally different. Are you okay? Excuse me. So choose a particular language because some languages have built-in capabilities that make them more efficient than others for handling certain types of operations. Is that okay? So some languages are better at handling how to do a particular thing than others. For example, like I said, C. When you learn C, you will love it because C can go beyond the variable and start talking about the actual breakdown of a variable into the memory slot, how the data is stored in memory. Are you okay? So then some devices can connect. So there are devices in cars, like we have what we call there's something in the car. There's control board. Very good. The control board in my car, in most cars, they have a program in there that talk to all the lighting, the traffic gator. Are you with me? Even for the car to, without the control board, most cars won't even start. Yes, and it's just a control board. You have petrol, you have good batteries and everything. It won't work because there's a program at the center of it. Are you okay? Okay, so coding the program is so important. This is a typical one. So as you can see here, it's a language. If you understand it, you do understand it, but it's so basic. Are you okay? It's up to you if you can understand it. Yeah, you go for it. Okay, so this looks more like some kind of function, but anyway, we won't go into it. It's too early. Yeah, you can also make use of the GUI. Okay, so in 10 minutes time, this Zoom meeting will end. We'll join again. We do one more session and probably we close. depending on how far we go. If you have a question, please ask it as we go, because I'm really moving at a certain pace. I can see that, guys. That's the way to go for you. This is the GUI, is graphical user interface. And as opposed to the graphical user interface, you can have a command line. So what we are looking at is a command line. You can actually interact with programs using command line. Is that okay? So it's also a way to communicate the computer. There's nothing wrong with it, okay? But people will say gurus always do that anyway. I also believe so. AutoCAD is not for programmers, but we use commands, you see. We can also use the graphical user interface for AutoCAD, all right? So these are all GUIs. All the things you're looking at right now, they are all GUIs. They are graphical user interfaces. Are you there? Are you actually looking at what I'm looking at? I doubt.
Yes, we are.
Because
Yes, we are.
I thought I was showing a different interface altogether, and nobody said anything. Anyway, step 6, programming steps. Step 4, the 6 programming steps. The step 4, translate the program into machine language. Are you okay? So some languages you have to actually compile them in machine language. But anyway, I think these days you don't have to worry about that. You just run it, and then that's it. You don't have to worry about whether you are being, you need to change it to machine language. That's not your business. Let me just say that. Test the program. In fact, testing the program can take days. Some programs can be a pain. You write it, and then you check it, you realize there's a problem, you edit it, you come back to it. It depends on the complexity. If you really want a serious programmer, put the program to production. So production is totally different from development. So here we are differentiating between development and then production. Are you okay? Once the program is tested adequately, it's ready for the organizer, for you to use it, and that is production. Are you okay? And that means that the program now runs, and then you keep monitoring it, and then when there's an issue, you solve it. Okay, any question? If you have a question, please ask me. If you have a question, ask me. This is the website that you go to. So I'm going to show you a website. You can go there and get the materials. You go to, if you are looking at my web page, I'm showing you a website. Go there, francis.ulasite.com, and you go to, I think I showed you that during the photogrammetry lecture. All right, and then you see computer programming / information science and programming. Go down, you see that I just finished the first PowerPoint. I'm going to the next one, and remind me to give you a handout, but you guys, you have to buy the handout for like 500 Ghana cedis, because there are only a few of you. I hope you're ready for it. Anyway, so please take note of the site and then go there, and then I want you to just prepare yourself. We don't have time, so please, you ask for this, and we are doing this for you. Be serious, okay? All right, like I said, programming makes use of what? Algorithms. Okay, so I'm not going to belabor it. I'm going to talk about this already. Creation of algorithms. It's creativity. Please, guys, if you are going to be writing a program, it's the two of you. If two people, if David, Elvis write the same program, they will look different to solve a problem. See how to cook banku. People come out with different ideas. Are you with me? The Fantis have their own way of making banku, and then the Asantis too have their own way of doing it, and then the Evers too have their own way of making banku. They all end up making some kind of food. Are you okay? It's a variant, different banku variants. Are you okay? The same with programming. If you're actually programming, then you realize that there are different ways of doing it, but you end up doing what? The same things. Are you okay? All right. So it's not rocket science, guys. Your ingenuity, be ingenious. think through. You can't write a program and you're always calling me, what should I put here? What should I put here? You should do it yourself. I'm sorry. Nobody can be creative for you. Okay. Nobody can be creative for you. You have to be creative for yourself. So when they give you, when you have to write a program, please work hard. Are you okay? Computer language and computers are just a means to express and execute the algorithm. So the most important thing is the algorithm, which are the steps. Is okay. All right. They are like the paint and canvas, not the art. The algorithm is the art. Okay. The algorithm is what? The art. Okay. All right. So this class is bigger than you think. Namido is actively a part of this class. Okay. Principles. Make sure you name both data and algorithms in a way that is unambiguous. So there should be a way to, if I what we call declare the variables. So a variable should be called a particular name, and you shouldn't have another variable with the same name. That would be very confusing. Is that okay? You should store and retrieve data using names and other identifying information. So we will now talk about names, variable names. Are you okay? We'll talk about it. No, later we'll talk about it. For now, let's move on. Okay. Multiply numbers, apply algorithm to data, both identified by name. Denote the order of operations. So we talk about operator precedence using Visual Basic. So we are in this class, we are using Visual Basic to understand how to write a program. Express choice based on data. So we're talking about decision making. So we should be able to decide, okay, if 1 is greater than 2, then do one thing. Like the Indians always say, do one thing. Are you okay? So they are not my friends because they are messing up with my app. Anyway, so A greater than 2. If A is greater than 2, then do one thing. Are you okay? Then do something. So this is programming. This is what I'm teaching you in this class, nothing more. So focus on it. Listen to what I'm saying very well so that you just please me somehow. Is that okay? So that is it. In this case, there's a command. If there's a command, then this is the condition. But then we should have declared A and get to know what A is. So A is an integer. Okay. So we can also change the value of A and make it 5, equal to 5. So you can see that in this case, A is greater than 2. That is true. But what if A is actually -1 or -2? -2 is not greater than 2. So this do will not happen. Are you okay? We are asking the computer to do something, but it will not be done because the condition is false. Are you okay? So we can put this in bracket. You know, most programming languages, the condition is just executed like that, you know. Also, so we learn about operators, like mathematical operators. All right. Like I said, if you have a question, ask me. We have 1 minute. We just rejoin with the same link. Okay. We have 1 minute and then we rejoin with the same link. Express choice. I've talked about that. Express repetition. So we can actually repeat. Are you okay? In fact, that's why we make programming interesting. We can do a million things. Are you okay? So I equal to 1 to 10,000. Okay, 2 times I. So it will be multiplying 2 times a set, you know, times 1 times 2. So 2, 1, 2, 2, 3, 4, 2, 4. To do that up to 1,000, you can do it for 1 million. Okay, so in Visual Basic, this is how we express repetition. Okay, all right. So that's basically it for now. In other languages, a way to do. Okay, guys. So thank you very much for now, and then